In this lesson, we are going to look at one of the most fundamental rules in application security. Never store a user's password as plain text. You will learn what password hashing is, how to do it correctly in a FastAPI app using passlib and bcrypt, and exactly when and why this approach is the right tool for the job. Imagine your database gets leaked. It happens to large companies regularly. If you stored passwords as plain text, every attacker now has every user's actual password. And because people reuse passwords, the damage spreads far beyond your own app. The core problem is that storing a password means possessing it, and possessing it means you can lose it. The solution is to never possess it in the first place. Here is the everyday analogy that makes this click. A fingerprint scanner does not store your actual finger. It stores a unique pattern derived from your finger. When you press your finger again, it derives the pattern a second time and compares. Hashing a password works the same way. You transform the password into a fixed-length digest, store the digest, and verify future logins by transforming the input again and comparing digests. The original password never needs to be stored or recovered. The solution uses two libraries working together. Passlib is a high-level Python library that gives you a clean API over many hashing algorithms. Bcrypt is the algorithm you should actually use for passwords. It is intentionally slow, which makes brute force attacks expensive, and it automatically adds a random salt so two identical passwords produce different hashes. You configure passlib with the CryptContext object, then call hash to store a password and verify to check one at login time. Let us walk through this code. First, we import CryptContext from passlib and create pwd_context, telling it to use the bcrypt scheme. That single object manages all hashing for us. The user in Pydantic model captures a username and password from the request body. In the register endpoint, we call pwd_context.hash, passing the plain text password. Passlib runs bcrypt, adds a random salt and returns a long digest string. That digest is what we store, never the original password. In the login endpoint, we retrieve the stored digest, then call pwd_context.verify with the incoming plain text password and the stored digest. Passlib hashes the input the same way and compares. If they match, the login succeeds. If not, we raise a 401. The plain text password exists only for the duration of the request and is never written anywhere. Here is what happens inside bcrypt when you call hash. It generates a random salt, combines it with your password, and runs a cryptographic function thousands of times. That repetition is called the work factor, and it is why bcrypt is the right choice for passwords over fast algorithms like MD5 or SHA-256. The salt is encoded directly into the output digest string, so when verify is called later, it can extract the salt, repeat the exact same computation on the new input, and compare the results. Because the function only runs in one direction, there is no way to reverse a digest back to a password. Reach for bcrypt and passlib anytime your app accepts and stores a password that a human will type. However, if you need to get the original value back later, for example displaying an API key to a user after generation, hashing is the wrong tool because it is irreversible. Use encryption or a signed token instead. Similarly, if you are just checksumming a file for integrity, a fast algorithm like SHA-256 is fine. Bcrypt slowness would be unnecessary overhead. And if you are delegating authentication entirely to an Auth provider, you never hold the password at all, so none of this applies. Let us close with the 4 things to remember. First, plain text passwords are never acceptable. A breach becomes catastrophic the moment you store them. Second, passlib with bcrypt gives you a clean two-method API, hash to create a digest on registration, verify to check it on login. Third, bcrypt is intentionally slow and automatically salted, which defeats both brute force and rainbow table attacks. Fourth, hashing is strictly one way. If you ever need to retrieve the original value, hashing is not the right primitive.